Good afternoon, everybody, and welcome to this webinar of the Administering School ICT Infrastructure course, Developing Your Knowledge and Skills of the European Schoolnet Academy. My name is Nair Carrera, and I'm one of the moderators of this course, along with my colleagues Jean-Noel Collin and Roger Blameyer, who are also here. Very warm welcome to all of you who are joining this webinar today. I saw many places on the chat, so we got Poland, Portugal, Lithuania, Croatia, Belgium, France, Romania, UK, and many more. So we are very happy to have you here with us today. This webinar, as usual, will last for around 1 hour, but if you have to leave or anything, it's fine because we are recording the webinar and we will share it afterwards in the relevant section of this course, which is section 1.6. So we are now working on module 1, which is about optimizing your school network. And to guide us through this very interesting topic, we are honored to have a great speaker today with us. His name is Mark Kayat. Mark, welcome.
Thank you very much.
Mark is one of the many success stories of the Cisco Networking Academy. He started in 2001 by being a Cisco Certified Network Associate Student Fellow by Security and Cisco Certified Network Professional. He began teaching Networking Academy courses in 2007 to students and instructors while being involved as well in the industry as a network consultant and a telecom engineer. He joined Cisco in 2011 as a technical manager for Cisco Networking Academy, covering both the Middle East and the North Africa region. He also holds a master's on engineer and in electrical and computer engineer, and a Cisco certified internet work expert in routing and switching. So I believe he is the right person, perfect person to guide us through this topic. I hope the introduction is okay for you, Mark. If not, feel free to add anything you may consider.
No, thank you very much for the kind words in there. And I'm honored to be here among the administrators of the European SchoolNet. Last year, I delivered a session around IoT, so this year is going to be around networking. It's great, and I hope that the following slide deck will be of interest to everybody over here. Let's have as much engagement and interactivity as possible. There's a chat window over here.
Yep.
Make sure you use it. Any question you have, please do ask that question. And then either I'll take it as soon as it pops up in front of me, or I can pause, every section to see what available questions are there. And also towards the end, we can have a few minutes for some questions and answers. Is that fine, Nair?
Yes, it's perfect. Thank you, Mark. So whenever you want, the floor is yours.
Okay, great. So the title of the session is essentially you and your network, and we're talking over here things to know when designing a certain network, and not just about designing it, but also maintaining it. Now, as you will see in the upcoming slides, when you talk about networks, I mean, we can simply start with a simple network between two PCs. That's a network, and the internet, that's a network. So we really need to define what level or the complexity of the network that we're looking at having. Now, when we are talking about a network at a certain school, then over here, the network is considered as a medium size network. So anything that is, let's say, above 20, 30, 50 PCs, maybe it depends actually on the layout of the PCs as well. So anything between, I would say, 50 and 1000 PCs, I would consider this as being a medium network, small to medium network. And then, anything that goes beyond 1000, then for me, I consider this as being a large network. So based on these metrics, you would be able to, let's say, categorize the network that you are managing within your school. So we're gonna be is there any annotation tool over here, like an arrow or something?
There is a pointer. Yeah, there is a pointer here in the upper menu at the let's you in the upper part of the screen, next to the stop sharing button. There is an arrow. Okay, there you go.
Yes, I see it. Thank you.
Okay.
Okay, first time I'm using this tool. So we're gonna talk about the networks and then something that is extremely important, and that is the addressing scheme. Now, when we're talking about addressing, we're gonna mainly be looking only at IP version 4 addressing. IP version 6 is, let's say, currently is considered as something new, but not many institutions are actually adopting it yet. They are trying as much as possible to extend the lifetime of IP version 4. We'll talk about that in a few minutes. And then we'll be talking about the connectivity option, and that refers to how you, as a network, can be connected to the internet. Then last, design tips about how to build a small network, and then, of course, how to secure it. So yes, we are putting some security into this game over here. So to start off, I'm putting over here a slide that shows different industries, right? So not just education. We are looking at point of sale. We are looking at taxis, hotels, music, and so on and so forth. Why am I putting this? Well, as you know, the whole world is changing, and the whole world is becoming more and more connected. Now, these are industries that have existed for the past 20, 30, 50, 100 years, and maybe even more, especially for hotel, right? How did the technology change those industries? So the internet actually changed them. And whether you look at, for instance, taxi, how did technology change the taxi industry? Well, by solutions such as Uber or Lyft or Careem, right? We have so many solutions that have changed how taxi industry works. The hotel, we're talking about Airbnb, for example, where every home, every apartment is now considered as being a hotel, a potential hotel. So the network is becoming extremely important, and that is why at your own school you can also, make great things happen because you are leveraging the power of the network. So the network is going to be something that is of extreme importance to us, and that is why today we are focusing our discussion on networks. Now, as I said earlier, for me, I would say small. So you see over here, small and home networks. Then we've got the SOHO, we've got medium to large, and then we've got worldwide networks. The small home networks, that's when you have like a couple of PCs connected via one router that connects you to the internet. Usually it is Wi-Fi, right? And like maybe we have one router, one wireless access point, which is at the same time a router, an access point, a firewall, a switch. So you've got all sorts of devices in one device. Typically, you only find this in the homes because when you go into enterprises, you will find dedicated machines. So this machine, or we call it appliance, this appliance will be our router, this appliance will be our switch, this appliance will be our firewall. Why do we do that? Well, because when we talk about enterprise level networks, there's going to be a lot of load on those devices. There's going to be a lot of demand. There's going to be a lot of traffic. And with all the traffic and with all the communication and data that is flowing throughout the networks, you need to optimize performance. And for that, every millisecond of delay actually counts. And that is why you have specialized equipment that serve a specific purpose. So over here, we'll not go over the details of what is the difference between a router and a switch. In case you have heard these terms over here, we'll try to keep it at high level. But if you want to go technical, I love going technical. So let me know via chat if you have any specific question that I can help with. So we've got the small networks, we've got the SOHO. The small office, home office over here refers to a small company or maybe a startup that has, um, 5, 10, 15 PCs, something around that, 20 PCs maybe. And if you have, also at home, you have maybe a bigger home, you've got multiple areas in your home. This is your work area, this is the entertainment area. Then you may have what we call the SOHO. Then when we think of medium to large networks, as I said, medium, anything for me, goes to, 50, 100, 500, up to 1,000. Again, it depends on how they are set up. Then large, for me, large network is something huge, right? We're talking Cisco, for example. You've got a company that has, 70, 80, 90,000 users. So with all these users, you've got computers, laptops, you've got tablets and cell phones and smartphones. All of them are connected to the network. So actually, you've got maybe 200,000 endpoints connected. This is like the user endpoints, and you've got also printers, you've got scanners. All of them are connected to the network. So this is a large, or even what you consider as a huge network. And then we've got the worldwide network, which is the internet. The internet is actually a network of networks. So I hope the slides gives you an idea of what are networks, and the different, let's say, terminologies of networks. Now, usually in every network, or in the majority of networks, we have this type of communication scheme. You've got client-server communication. Client-server is when you have computers communicating with a certain server. So what is that? You've got, for instance, like what we're doing right now. You are users, you are end systems or clients connected to a server, which is actually um, the uh, the control system on Adobe Connect. So even myself, I am a client because I am connecting to Adobe Client as a server to be able to take part in this collaborative meeting. So this is a type of client-server communication. The easiest way to think of client-server is when you go to any website, www.cisco.com. So you're going from a certain client, which is typically the receiver, going into a server to get the data from that server. Within your university, typically you've got servers that would include or contain the grades of your students, the basically the student information system, so the SIS, uh, which includes their data, their personal data, their track, their grades, all the information. You've got the course schedule and all of that. So this is they would be typically stored in one or multiple servers, and then the clients or the user would be able to connect to that server to get that data from. Now, this is one type of data or data communication. Another type is peer-to-peer. So over here, you've got, for example, an example of file sharing and printer sharing between two devices. Typically, at home, if you at home you have multiple PCs and then you can share files between one PC to another. Uh, I don't know if anyone over here has done it, but basically you can pick any folder if you're using a Windows box, and then you hit right-click properties, go to tools or advanced, and then sharing, and voila, you can enable another user on another computer to be able to connect to you. So this is called peer-to-peer communication, which is it doesn't entitle any, it doesn't include big robust servers. We're talking about PCs at the same grade or laptops at the same grade. So it's fairly something not so complex. It's quite easy to configure, but of course it's not scalable. It's something that is restricted to a couple of PCs. So this is called peer-to-peer. So in terms of data communication, as we saw, there are two main types. We've got the data, we've got the client server, and then we've got the peer-to-peer communication. Now, going from that, we can start talking about the different elements in our networks or the different components. So in a network, typically all elements or things in the network are categorized either as devices, media, or services. So what are they? Devices, well, over here we have, well, you see over here all those that are highlighted or outlined with orange, these are our devices. Devices could be endpoints like computers, IP phones, servers, we could have printers, network scanners. All of those are considered as endpoints or end devices. And then we've got intermediary devices, such as what we see over here, routers, switches, firewalls. Typically, these are some devices that are used so that your data goes through them, right? So these are networking devices. Anyway, we'll see them in an upcoming slide. The next set over here is the media. Media, plural of medium. The media is essentially any cable, any wire, any wireless transmission method we're using. For instance, Bluetooth, infrared, Wi-Fi, Zigbee, WiMAX, satellite communication. All of them are considered as media. We've got the cables also. If you've heard of the Ethernet cable, which is essentially a Cat5 or Cat6 cable, these are called media. Okay, so they actually take the data from one device into another device. Then we've got, of course, the services. The services over here we refer to anything that is running on a certain server, which allows user to access, such as a web service, an email service, or a DNS server. DNS, I'm gonna put it in. Let me use the chat for the first time. So DNS. What is the DNS? DNS is the domain name system. So, for instance, when you type www.cisco.com, in real IT world, there's no names. There are no names. So you cannot really use cisco.com as a destination, right? In your actual packet for the data that goes from your computer to the next device, which is a switch. So DNS is domain name system. It allows the conversion of a well-known name such as cisco.com or EUN or other into a certain IP address, and the IP address is effectively the telephone number. So the DNS is something like your phone book, right? You know by name your friends, but not necessarily by their phone numbers. And the phone book is actually that. So you see over here on these slides, we see the end devices as well as the intermediary devices. And these are network media. You see over here, we've got copper. And typically, these are the three types of medium that we have. We've got the copper. Copper here, we're talking about Ethernet cables, such as this one, which is what we call the Cat6. We have the phone line. It's also copper cable. We've got the coaxial cable. All these are copper cable, and they typically transmit electrical signals. Now, another type is a fiber optic cable. A fiber optic cable is essentially a cable made of sort of glass, and it doesn't transmit electric signals. It transmits light signals. And because it's light, then this is the fastest possible medium. And we can reach speeds of huge numbers, and this is with the fiber optic cables. And essentially, how the whole world is connected is using fiber optic cables. Not wireless, not copper cable, no, just fiber optics. So, for instance, there are some submarine cables running from Europe to the US to Cyprus to Egypt to Lebanon, and so on and so forth. So all the countries are connected via fiber optics because they allow for a lot of transmission speed. Actually, you can go on the internet and you can simply Google the, let's say, world map of submarine cables, submarine um, fiber optic cables, right? And you should be able to find a certain map. Actually, this is, let me just give you the sites. It's quite a nice site. Let me put it over here. So actually, you can go and search your region to see what cables are available, and you can find a lot of information on those cables by clicking on them. You may be able to get information where it's connected, to where it's connected, who are the owners, and so on and so forth. So that's actually quite interesting to get a look from a global level and drilling down to a smaller zone. For instance, I can see that Iceland is connected to Greenland and then connected to UK and actually connected to to Denmark. So that's interesting. I didn't know that about Iceland. Anyway, so you can actually go and have some fun on this site. It's a very interesting site. Great. Moving on. So I was talking about the DNS and how the DNS is like the phone book on your smartphone. So, for instance, if you store my number, you don't need to memorize my number. You just need to know my name. Well, in the world of internet, there are no phone numbers. There are what we call IP addresses. And IP addresses, historically, we have had IP version 4, even though we had other protocols, but they are less common. So over here, we have IP version 4, which is today, it's the de facto protocol. There is IP version 6, but it's actually 4 times larger than this. Okay, and the problem with IPv6, well, it's not the problem, but anyway, I'm not judging. IP version 4, you see, it's represented as a 4-octet decimal. So it's A dot B dot C dot D, and each one of those A, B, C, and D is actually a decimal number that can go from 0 until 255. Okay? So you could have a theoretical value of 0.0.0.0 until 255.255.255.255. So this is, let's say, the minimum and the maximum value. Whereas when you look at IPv6, IPv6 is something that is, because it's huge. So IP version 4 is, let me put that in the chat, IP version 4 is 32 bits. But when you look at IPv6, it's actually 128 bits, which is 4 times larger than IPv4. And a typical format of IPv6 is 2001. Everything is in hexadecimal. So the digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, of course, A, B, C, D, E, F. So it could be something like that. I'm putting stuff in the chat. 1 second. When I hit enter, you'll get it. A, 1, 2, 3, 4, 5, 6, 7, 8. So I just put in the chat right now an IPv6 address. So you tell me if IPv6 is easier than IPv4. I'm not judging. Just look at the chat and see the 2 examples of IPv4 and IPv6. Anyway, the future is definitely IPv6. That's for sure. But that is why people, until now, are trying as much as possible to stay with IP version 4 simply because it's a lot easier. And not all ISPs, Internet Service Providers, not all of them are able to route, let's say, IP version 6. And to Zlatko's question, IPv6 is 128 bits, not 64 bits. Okay, the mask is 64 bits. Okay, just like the default mask, sorry, is 64 bits in IPv6. Anyway, so today We will not go over IPv6 because it might be considered as a more or less advanced topic. So all devices in your network, all devices in the network are having an IP address, whether IPv4 or IPv6, it's an IP address. Now, there are two ways of how you can assign an IP address. Either statically, so by you going to your computer or your device, which could be a printer, which could be a smartphone, which could be any device, um, you can assign statically an IP address. This is not a common practice. Typically, you do this only for servers, only for printers, maybe. So stuff that should always have the same IP address. And by the way, the screenshot is taken from a Windows machine. So on your Windows, if you want to change the IP address, typically you would land on a window just like this one. The other option would be to obtain dynamically an IP address, and this is a method using a service called DHCP, if you want to Google that up, which is Dynamic Host Configuration Protocol. Typically, your smartphone, like I would say 99% of the smartphones, by the way, can you tell what smartphone I have if I hold it like this? That's going to be your pop quiz of the day. And those who win will win this smartphone. I'm kidding. Um, all smartphones typically connect via Wi-Fi to the network, and it's DHCP, so the IP address is given dynamically. And when it's given dynamically, it's getting an IP address via DHCP. But however, on your smartphone, you can go and set an IP address statically if you wish to do so. So this is the DHCP, Dynamic Host Configuration Protocol. This is this protocol that allows the devices to receive an IP address automatically, and this IP address is managed by the server. So again, looking back at your home network, the DHCP as a service is running on your wireless router, and the wireless router is giving these IP addresses to the host in the network. Okay. If you're looking at your school network, well, in the school network, you should have a DHCP server. Why? Because you don't want to manage all IP addresses of all computers in your network manually. So you want to have a certain server that will lease these IP addresses for a certain period of time, and then it will simply renew. As simple as that. And because typically in your school you may have anywhere between 50 computers and 1,000 computers, maybe more, maybe less, but I would say majority of schools have between 50 and 1,000. Then you cannot run this DHCP server on your wireless router. It simply wouldn't work. It would crash. So you need not a proper machine as a server. However, on a server that is running even, let's say, your intranet or your storage for the network, then you can have the DHCP running on that as well, serving the whole network. Now, planning for IP addressing is also going to be very important for a number of reasons. One of them is to have things in a very clear way. Another thing would be from a security perspective. So planning IP addressing over here, we have a term called subnet. Subnet, this is a portion of a network. So I've got 1,000 computers. It's going to be impossible to put those 1,000 computers in one network because this will actually degrade the performance, like drastically degrade the performance. And this essentially wouldn't be the best design you could have for a certain network. So we need to plan the addressing, and planning the addressing, as you see over here, from security perspective, it would be great, and also in terms of performance enhancements. Now, we would be typically grouping user types, such as students, or maybe not even all students. Maybe students of grade 5 are together, students or computers of students of grade 6 together, grade 7 together, and so on and so forth. So we can do that. And then, as I said a bit earlier, if you remember, I said that for servers, we could, statically configure them. So you see over here, you've got host devices. Host means the regular computers from, dot one, which is the first IP in a certain subnet until, this is an example, of course, until 229. And then everything that is above 229, remember it goes up to 255 theoretically, then these addresses would be reserved for some specific uh, devices such as servers, printers, routers, and switches. Now, it's a common practice to put these statically needed devices towards the end or towards the beginning. Okay, so this is typically how addressing is being done, keeping in mind that from security perspective, we would be dividing our big network into smaller chunks of networks so that we have better performance and better security. So in terms of performance, this is the slide that I'm referring to. You see over here, by the way, I've got a comment that this slide is empty. Nair, can you confirm that you or someone else can confirm that you see the slide?
No, I can see it. So I don't know if it's a problem with
Okay,
Cohen,
okay.
but
Just
I
wanted to
can see
confirm
it.
it. Okay, perfect. Thank you.
Yep.
Thanks.
Okay.
So, great. Thanks for the confirmation, guys. Um, Again, going into the example of 1,000 computers. In networking, there is a term called broadcast. So, what's a broadcast? A broadcast is assume you are all sitting in a classroom, and so let's say you are all students, and an instructor goes into the room and says, "Hi everyone." What will happen? Right? Everybody will respond. Right? It's like, "Hi sir." That is broadcast because everybody responded to that message. And when the instructor said, "Hello everyone," he's saying hello to absolutely everyone. So sending a message to everyone. Now imagine you have 1,000 students, and then you've got one of those users, which could be an instructor and it could be any other computer, that says, "Hey guys." So what will happen? The 999 other users will respond to that message. And this will cause what we call a broadcast storm. And because their response might trigger another broadcast. So this actually degrades the quality of degrades the performance of the network and lowers the quality, and that is why this broadcast domain will have to be divided into smaller broadcast domains. So one LAN, one network. LAN stands for local area network, which is essentially a network. So as I said, a broadcast domain is something huge. So the network will have to be split into smaller networks or multiple networks. So as an example over here, on this slide, you've got 400 users. Then I can split it over two networks and have 200 users. And notice over here, the network will actually change. Now, I will not go into the philosophy of IP addresses and subnetting and how to create different networks. But let's just say that there are different networks over here. They are separated by a router, which effectively stops those broadcasts. So if you've got over here in LAN 1, you've got a user that says, "Hey guys," who will respond? The 199 other users in that same network. So here's the question. Will the users in LAN 2 hear this message from users of LAN 1? The answer is no. They will not. And this is good because the broadcast should be contained. Imagine, since we here are in a network of networks, right? It's the internet. If here, where I'm sitting right now, if my computer says, hey guys, how many devices do you think will respond to me if broadcasts go through the internet? What is the actual number of devices currently connected to the internet today? We've got maybe 20 billion devices, or 15, or 20, or 25 billion devices connected to the internet. I said billion and not million. So 25 billion devices connected to the internet. Imagine all these 25 billion users are going to respond to my, hey guys, what's up? So that's why we are creating a smaller networks. So over here in my home, I'm actually right at home, right now at home. I've got, multiple devices. I've got two laptops, a TV, like three, four smartphones. So essentially maybe 10 devices. So if I say, hey guys, I've got only 10 devices that will respond to me. That's it. So the broadcast will not be relayed to the ISP. It will be stopped over here. So when we're designing our network at the school, we will be creating different LANs or different networks. And these different networks, every network will be its own broadcast domain. So the broadcast will be contained within a certain network. And this is very good. This is something that we want to do. But definitely, we don't want to go extreme in this. We don't want to create a network for every two users. Okay, we want to create a network for every 20, 50, 100 users. That's it. This would be good practice. Now, think that you have created the design and then, you need to connect to the internet. So how can you connect to the internet? Well, of course, there are multiple options. Um, so you need to connect to your ISP, and there are so many different ways. Sorry, this cable over here is coming on this word over here. So now it's showing just as Ethernet, but it's actually Metro Ethernet. So over here you've got different access technologies. DSL is very common. I don't know if it's common where you are living right now. However, it's common here and there, right, in different countries, in different areas. Broadband cable, this is something very, very common. At home, you may have DSL, you may have mobile service, you may have wireless WAN or WiMAX. You could have Metro Ethernet. This is something that is um, mostly used for companies, especially companies that have multiple branches. So this is a way how they can connect multiple branches together over the ISP's network. So there are so many different ways of how we can connect to the internet. However, once we are connected to the internet, it doesn't really matter what technology we have used. If it's a broadband cable, if it's DSL, if it's other, it doesn't matter. What matters is that I should receive an IP address from the ISP, or let me reword that. I should establish an IP connectivity. So connectivity at the IP level with the ISP. So I don't really care about how I connect to the ISP as long as I connect to the ISP. And then it's all transparent. So you see over here a DSL cable, cellular, satellite, dial-up, even though this, of course, um, we shouldn't find this. The problem with dial-up telephone is that it is limited to 56 kilobit per second, which is very slow. Can you imagine today in 2018 going back to 56 kilobit per second, like how it used to be, at least for me in the not even 90s and until 2002, 2003, 4, I was still on dial-up. Yeah, poor little Mark. For businesses, and typically your school would be one of them. They would be connected to the internet using other methods such as DSL or business DSL or HDSL, which provides for a higher throughput, a lot of upload and download links, both of them. Um, Mario, you really miss those dialing tones and waiting 30 seconds to be connected. Really? um, So we've got now dedicated lease lines, we've got satellite connectivity, we've got DSL, we've got fiber optics also reaching to the companies. So this definitely adds to the connectivity speed and flexibility of our connections. Now, sorry. So when we connect to the network, there are still some considerations for us. So most importantly is the communication within the network and going outside the network. So a bit earlier, I was talking about routers and switches, right? You see over here, this is a switch, and this is a switch. Typically, a switch is represented as a rectangle, let's say, or a how do you say a rectangle when it's in 3D? Um, I know it in French, but I'm trying to think about it in English. No, not a cube. A cube is like when it's square from the four sides. Parallelogram, yes. What I've got over here, multiple languages, I think. So, so yes, parallelogram. Um, so over here, this is a switch, and for a router, it's typically a disk or a cylinder. So over here, a router is actually a very important element in our internet because the routers are separating networks. So over here, when looking at this diagram over here, let me take the drawing tool. So when you're looking at this one over here, we can easily see two networks. This is one network, and then over here, this is another network. You see, the switch, all of it is immersed in a network. The router does not take part in any network because the router delimits the network. So if you want, this interface of the router is in this network, and this interface is in this other network, right? So how do I delete them all? Okay, I have no idea how to delete. Okay,
It's fine,
now
yeah.
yes, yeah. So when you do the communication within your network, you don't actually go to what we call a default gateway. But when you want to communicate with a device outside your network, you need your default gateway. In other terms, if you look back at your home network, you have your uh, you have your um, you have your PC, and if you're communicating with another PC in your network, then you don't need to reach out to the wireless router. You don't even get to the wireless router. The communication is stays within your network. If you want to go to beyond your network, then you will reach out to your default gateway. So at school, if you have PCs next to each other, they will communicate directly without reaching out to the uh, main communication server. Now, a term that is very important is NAT. Specifically, if you're using IPv4, IPv4, it's limited. So IPv6 is also limited, but IPv4, uh, it's limited to roughly 4 million IP addresses, right? Because it's 32 bits. So if you have a calculator, calculate 2 to the power 32, and you get the total number of IP addresses. And not all of them are used, right? If someone wants to do that over a calculator and then put the result in the chat, it would be interesting. So this address, actually, it's not 4 million, it's 4 billion, if I'm not mistaken, 4 billion and something. So we've got limited number of users, limited number of IP addresses. IPv6 has, if someone wants to try IPv6, so for IPv6, you can try it on your calculator. It's 2 to the power 128. Get that number. I don't know if you are able to copy and paste such a long number. So try that. So for IPv4, we have very limited number of IP addresses that we can use, and that is why we use NAT. For instance, the 4, 5, 10, 15, 20 devices that you have at home, When they go on the internet, they go on the internet as one IP address. So they get what we call NATed. NAT stands for Network Address Translation. So typically we can have, let's say, 4,000 hosts share one IP address on the internet. That's typically what is done. So actually, if you check on your PC right now or on your smartphone, if you know how to check the IP address, let's say if you go into the command prompt, the Windows DOS, right? And if you hit the command ipconfig if you're using Windows, or ifconfig if you're using Linux, then you will see that you have most probably an IP address that is either 10.xxx or 172.16.x.x or 192.168.x.x, right? Um, Most probably you have one of those three ranges of IP addresses, because these IP addresses are in the range of in the RFC of 1918, which is considered as private addresses. So when you go on the internet, you actually go to another IP address. So if you were able actually to get your IP address on your local machine, or maybe even on your phone, so go to the wireless settings, you should be able to see what is your IP address. Once you do that, go to this website. This website will actually tell you what is your IP address from the how the world sees you. And most probably, the IP address that you will see on this website is going to be different than the IP address on your local PC. And that is because you are being natted, right? Most probably, if you and the person next to you, you go to this website, whatismyip.com, you will see the same IP address, even though locally you have a different IP than he or she has. So this is the RFC 1918. You see the three ranges over here. And this picture shows, or diagram shows, how IP address, a private one, gets natted into public IP address. And this is called NAT. Now, reaching towards a bit towards the end of this slide deck, so about designing networks. So when we want to design a certain network, um, here we need to, of course, for us, we are only thinking about small networks rather than medium or large networks. So small networks typically have a very simple design. Most importantly, because we've got this one machine that does everything. Like I said, for instance, in the case of my home, I've got, and not just my home, but majority of your homes, we've got one router that does everything. But when you look at it from a school network perspective, typically you would have almost the same design. You have a switch connecting the PCs and the servers. And then if you have a larger school, then maybe every room has its own switch. They would be connected together, and then they would be eventually connected through a router that will do the routing or separation between those networks, and then routing towards the internet. So this is typically, in a nutshell, the design for a small network. But there are some things that will contribute to your choice of equipment and the choice of services that you want to include. Of course, we're talking about the cost of the equipment. So if you're getting a Cisco switch, or you're getting some other brand of switches, then what will be different? Is it just the cost? Is it the port density, or the number of ports? The speed, the maximum speed that can be transmitted throughout those ports? So what is it, right? So you have to really think about it, not just from dollar value perspective. You have to consider other elements as well in order to do the right purchase of your device. It's important to have some redundancy in a network. So this means that you see over here, I've got, especially this is important for servers. So you've got three servers. Your data is split over those three servers. So if any one of those three servers goes down, then the data is backed up over the other two servers. So operation should be carried on normally. You've got two switches. So if any of the switches goes down for whatever reason, then communication should still be able to function normally. And you see every switch, every server is connected to both switches. Again, if a switch goes down, then a server will still be able to contact, the remaining of the network with two routers, probably going through two different ISPs. So this is typically a mini data center, or what used to be called a server farm or a server room. Okay, and essentially you want to simply eliminate any single port of failure. So you want to remove that because you want to make sure that if something happens, your network stays up and running. Now, last section is actually security, which is always a very important topic. So the security, we'll not go into a lot of details of security, but um, whenever you talk about security and threats, people always think, yeah, I'll be attacked from the internet, so I'll put a firewall and I should be safe. And this is where everybody is almost wrong. Majority of the attacks, more than 60-70% of the attacks, are actually initiated from the inside of the network. So putting a firewall at the edge of the network doesn't protect the inside of your network. So that is why you have to think of how you can protect the inside of the network by installing antiviruses, by installing intrusion detection and prevention systems, by installing security agents, by creating different sort of security policies, because all of these, the combination of all these solutions will contribute to a safer network. Security isn't restricted only to software, but also to hardware and to physical security. And this is quite often something that is simply forgotten by some administrators. So you've got an administrator that, does all the required passwords and, security policies and firewalls and IDS and this and that. But then what? They leave the switch on the table just like that, unprotected. So if someone simply unplugs the power on that switch, that's it. He created a denial of service attack or a DOS attack. That can put it in the chat. DOS attack. Okay, so um, you wanna consider physical security as well as data and software security. Vulnerability could be typically of three types: technological, configuration, and security policy. Technological refers to a flaw in the protocol. For instance, if I go to a website with HTTP, right, then this is a technological problem, right? Because data that is sent over HTTP is unencrypted. So anyone can actually eavesdrop and can capture the data that you are sending. So a better solution would be, of course, to go for HTTPS. So this S at the end is actually the security aspect. Configuration is when you do some configuration errors and you create some loopholes in your network. And security policy is when your policy isn't strong enough in terms of enforcing a certain password or the check on the system and so on and so forth. Attackers typically gain access to the network through one of these three different malwares: the viruses, the worms, and the Trojan horses. Each have different, let's say, behavior, but essentially all three of them are harmful, and we don't want to have them in our network, right? Trojan is when you have an application running in your network and you think it's a good application, but it's actually very bad. Worm is something that goes throughout the network and infecting multiple devices. And virus is this essentially the malware, the bad software that deletes your data, encrypts your data, and so on and so forth. Typically, any type of attack is preceded by the reconnaissance attack, which is some sort of scanning of the network. This level of attack would be very hard to prevent because it may seem like a legitimate user who is scanning the network to see what devices are up, what services are available, so that later on they can attack them. Then you've got the access attacks. Access attacks is when someone is able to exploit a certain network and take some sort of action, stealing data, doing other stuff. Okay. Then after that, of course, in order to be in a better shape, we have to always keep ourselves updated. And when we have everything updated in terms of operating system, in terms of tools and software, and we have our data backed up, then we should be in good shape. Especially at school, you want to consider the AAA, the authentication, authorization, and accounting, because this is something that allows you to assign privileges on a user level. So this means that what a student is allowed to do, what an instructor is allowed to do, where is he allowed to go, where is he allowed to visit in the network, and to keep a log, so the accounting of everything that he or she does. So this is AAA, something very important, which you should be considering when you're planning on having an enhancement to the network at your school. As I said, firewall, this is something very important. However, it only protects the access towards my network, not whatever happens inside my network. Now, we're seeing over here the appliances, which are the hardware-based firewall that protects my network from external access. But you also have personal firewall. Personal firewall, this is something that protects your PC. So protects your PC from external access, which means from access from other PCs inside your network. So this is a very important element in terms of security. Last but not least, passwords are always very vulnerable because we tend to use easy passwords, easy to remember passwords, easy to guess passwords, sorry, not to remember. Not a huge mix of small letter, capital letter. People use exactly as Mario is putting 1 to 8 or 8 to 1. If someone wants to get creative, so goes 8 to 1. So this is some definitely, in our policy, we should say that passwords should be at least, 8 characters long or 10 characters or 12 characters with a combination of this, and that. Anyway, so with this, I would have covered, oops, power outage. So I would have covered my course around network. Now over here, I will leave here a slide that shows a list of courses that have been created for you, a course on cybersecurity and course on Internet of Things. These are relatively short courses. We're talking 10, 15 hours every course. And if you want to enroll in them, you see over here, pick the language of your choice: English, Spanish, French, German, Italian, Portuguese, Hebrew, and Polish. Over here, sorry for the typo over here. So these are courses for cybersecurity and Internet of Things that you may find very interesting. So I hope this has been useful for you. Let me see questions that you have in the chat. I noticed a couple of ones over here. So there's one around difference between authentication and authorization. So here's a simple example. So that's a question from Christian. So Christian, authentication is for me to make sure that you are Christian. Your name is Christian. So I want to make sure that that is really you. That's authentication. Now, authorization is what are you allowed to do? So are you allowed to access that file? Are you allowed to print? Right? So AAA is authentication. So who are you? I want to make sure that you're the right person. what are you allowed to do, and then accounting, I want to log what you are doing. Okay, let's see, looking in the chats. Okay, there's one from Arnoldas. What is better for network when sub-leveling from main router, other router, or switch? So over here we've got a router and then going downwards. It depends actually on what level of switch or router. I mean, what grade is it? A you know, $20 switch or a $1,000 switch, right? There's a difference in terms of the capabilities of those devices. I would say a switch if it's a multi-layer switch, so that you can also expand the network beyond that. But a multi-layer switch, of course, wouldn't be something that you can buy just like that off the shelf for $50. This would be something that would cost typically $1,000 or maybe more. Of course, starting point, and this allows you to have some routing functionality at the switch level, and allows you even to further break down your network. But it depends on your design. If you have a network with 1,000 users, then definitely you need multiple what we call layer 3 devices. So a router is a layer 3 device, or a multi-layer switch is also considered as a layer 3 device. I hope I was able to answer without putting a lot of complexity. So essentially, both are right answers, but it depends on the size of your network. Great. Let's see.
Thanks, Mark. There was another question asking what is the difference between a switch and a hub?
Okay. Difference is 15 years. A hub is something that used to be common in the 80s, early 90s. Mid 90s moving forward, it's about just switches, no more hubs. So actually, even though nowadays we've got people that say, "Hey, I've got a hub connected to, or 10 PCs connected to a hub," but effectively they have a switch. They don't have a hub. A hub, as Mario said, the switch is much smarter than hub because it can identify users based on another type of address, which is called a MAC address. So just like we have the IP address, which is like the phone number, we've got something called the MAC address, which is actually a hardware address. Now, a switch can recognize that, a hub cannot. So a hub sends the message to everybody, whereas a switch only sends it to the person who should be receiving that message.
Great, thanks, Mark. There was another question. Yeah.
Yeah, from one router plus five switches. Is that a math problem? Like and formula, like okay, one router, 5 switches.